This recording is for Primary Math 6. We're working on the class recording for week 3, and this week we're working in the workbook exercises 4 through 7, intensive practice page 12 through 16, and the challenging word problems has no assignments this week. So it's a little bit of a shorter week actually. It's a very different topic, and I want to give you a little encouragement. Some of your students have maybe struggled last week in the algebra assignments. Those are a little bit abstract and unusual for us. This week's topic is called solid figures. Basically, it's 3D picturing how to fold up the images and how it would look when it's folded and things like that. And so it's all about solid figures. And it's another kind of a different kind of a week, different kind of a topic. But for those of your students who are uncomfortable with these topics, we'll get to ratio, percentages, and speed real soon and kind of go back into what we would normally feel like is the flow of Singapore math. But we start off with 3 weeks right off the bat of a little bit of unusual kinds of topics. Some of your kids will find these to be very refreshing and enjoyable, and you'll learn something about your kids when you see that going on. In the workbook, exercise 4, very basic. We're just learning to look at a real-life object and recognize the figure, the solid that it's made from. When you see on page 13, and it talks about faces, a face is just the faces of a solid are simply the number of sides. A side and a face could be used interchangeably. How many sides does it have? How many faces does it have? And so when you're looking at those, just counting how many sides there are, and certainly, as much as possible when they need help, make it concrete. Exercise 5 is where some of your students will excel and some of them will want to put their book away. I'm not going to try to draw every picture on all these pages, but I just want to give you a few ideas of how to help your child. Number one, if they have trouble looking at it in 2 dimensions, you could certainly cut something out and let them play with it and see what they can make out of it. But we would also like them to stretch their brain and try to learn how to look at something like this and figure out how it works. Some of them will be incredibly natural at it, unlike myself. So some of us have to work harder at it, and because I work hard at it, I can kind of think through how I would look at something like this and how to encourage your child to think about it. When I see letter A, I think of this one as being possibly the base, just because it is connected to so many different ones. And I can imagine if this is a side, and this is maybe the back, and I'm going to put the front on it like this because I'm imagining I'm going to fold it up. Okay, and this would be the left side, and then this would be the right side. Now, I wrote them that way because when you fold them up, standing up, they're going to be exactly the right way. They'll look like the letters are right side up. And then this one is the top. It's the one that's going to fold up over the top of it. So it says to circle the letters are the ones that can be folded into a cube. This one works just fine. This is the base, and we fold each of those 4 up, and then this one covers the top, making it a closed box. But imagine trying to do that with this one. Whichever one you try to make the base out of, okay, that could be the base, that's fine. And then this could be the back, and you could just kind of swirl this around to be the left side. And this could fold up to be the right side, but the problem is, well, and of course this could be the front, but the problem is that this top one, when you fold this up, these 2 won't really fold because this is in the way, right? It won't fold together, and you can't make it work that way. So this one definitely cannot be the base, and you could play with it a few times and see what you can find out, see if anything works. But really, because these 4 are connected right there, it's not going to fold. Think about folding something with connected on 4. You can't fold it into a flat and into a box because of that. So B does not work. I think it's interesting to note that you can make anything you want to be the base. Some things will be easier than others, but you can make anything be the base. And I think it's easier if you've got the one that's kind of the pivotal point. I'm going to call that the base. And I could see this one being the back, and then this would fold forward to be the left side. This can fold up to be the right side, which when that folds up, this one can fold over to be the top, and then what happens is this one actually folds down, and this becomes the front. Now I guess my letters are actually on the inside of the box, and so they're not really written forward if you're looking on the outside of the box. My letters are, anyway, doing my best to try and communicate a little bit of this. But notice that when you fold that up and the top goes over the top of it, that F flap will fold right down and be right there in the front of the box, and it will allow this line to connect to this to cover up the front of that box. Okay, so C is one that works. When you look at D, you'll find that it will not work. Again, often this, like this one, could be the base, and of course this would fold up to be the right side, and this would fold up to be the left side. And if that happens, this one has to be the top, and of course this one's going to be the front. It's just going to fold up, but then this one is right where the top is. These two are both sitting in the spot for the top, and this space over here has nothing to connect to it. Some of your students are going to look at this and realize, of course it has nothing to connect. This can only go in two directions, like up and over. This goes in two directions, up and over. There's nothing to put here, nothing to get to that point, so that one won't work. So I think that those are going to be the kinds of ways you'll talk about with your students. Again, some of them are going to get it, and some of them aren't as quickly, and you just got to work with them on that and make it as concrete as they need it to be. Page 15, just for the sake of definition, a cuboid. A cube is a six-sided figure that's the same. A cuboid means it's six sides, but they're not all the same. So they're not all going to be the same, but keep in mind, 4 have to be the same and 2 have to be the same in order for them to make a box, right? You have to have things the same so that it would make a box. So you can see on some of those why it would or wouldn't work. B is a great example. Notice how it has the bottom and the top like that, and then you're connected by the 4 sides. So when you fold those 4 sides up and you fold that over, these two have to be the same because they're the top and the bottom, and the other 4 have to be the same because they are all the 4 sides that are going to be matching each other in order to make it a cuboid. Letter D has the right shapes, but it's not the right configuration. Okay, you've got all of these shapes here, but you can't fold that to make a top and bottom out of these and 4 sides around themselves. Again, notice you've got those 4 intersecting, so it doesn't work. So there's whatever help that is. Hopefully that's somewhat helpful for those. Might just take some thinking and trying on those. Exercise 6, it gives us a solid. We want to know which of the following can be a net of the solid. In other words, if I fold it, I can make that trapezoid pyramid, I'm sorry, triangular pyramid over there. And so like, for example, A works just fine because those 3 rectangles, right, you just kind of fold them up into a triangle so that this side and this side are touching in the back, and it's going to make a triangle, right? And then you have a triangle on the top here and a triangle on the bottom here, and it's going to be able to fold over onto the flap and work just fine. But for various reasons, you can see that the others don't. The triangle that's supposed to be the top and bottom don't match. On letter D, they're the wrong shape. Okay, and so again, it's just a matter of thinking and looking and checking and figuring out what does and does not work on those problems. And then the rest of that, exercise 7 is similar to all of that. Nothing really new to go over there. In the intensive practice book, this week your student should accomplish pages 12 through 16. It is more of the solid figures. The information at the top of that page is helpful. It reminds us that a pyramid has a flat surface and it comes to a point. So my drawings are just shy of horrible, but a pyramid will always come to a point. Okay, and a prism is always going to have 2 shapes the same at the top and bottom. So, for example, a cylindrical prism, we really just called a cylinder. Okay, let's not go with cylinder, that's a bit of a different shape. Let's go with a rectangular prism. If it has the same shapes on the top and bottom, that's what makes it a prism. Okay, it's not a cube, it's a prism. A cuboid, okay, because it's 6 sides. Let's do a triangle. Same idea. Okay, this is a triangular prism because I have a triangle on the top, a triangle on the bottom. Notice that the other shapes are not triangles. I actually have 3 rectangles. Okay, and so that's a triangular prism. It's triangular prism because the bases, the top and bottom, are triangles. So, so it's there. The hint is there to give you the name of the solids. Curved surfaces means exactly what it says. Number of faces, remember, means number of sides. And so, again, just the terminology. Then you have more nets, you have more drawings, all very similar to what we had before. The only different thing that they added is on page 16. Let's talk about that a second. This page adds the extra level of difficulty in that the solids they draw up, what they're trying to ask is not can you make this into a solid, but what would one of them look like, and trying to decide which one actually works. And even the shape of the letters, the way the letters are written on the faces matters, and it shows which one is going to work. So for example, on that first one they show, I'm not even going to try and draw it, except the top face of it has an A sitting like this, and this face here has an E that is upside down. And notice that if you have an A and the E, they are touching, but the top of the A points to the E, and so the E shouldn't be this way, it would be down the back side of that. So it is very, very specific as far as which ones work, all the way to the way that letters are pointing, and could you actually fold it so that those letters are pointing in that order and are lined up in that direction. So it's quite an interesting thing. And again, you can get a real live cube or pieces of graph paper that you cut out or something so you can write it on there and make it as concrete as possible, see what it looks like. Number 5, also same kind of thing. They're trying to have you look at that and draw it out. And it'll just be fun for some of your kids and extraordinarily frustrating for others, and you can make it concrete in order to help them not be as frustrated by it. But just it's good brain exercise. It's good to use the other part of your math brain to cause you to see the different shapes and the different ways they come together. These kinds of questions are on a lot of like an intelligence test or like a learning abilities index or things like that that just help us to figure out, okay, are they spatial or concrete? What do they do? And certainly people who are good at this kind of thing are looking at, I don't mean to predict your child's future, but things like mechanical engineering, things where you really have to picture in drawings and picture what it's going to look like in real life. There's a real specific job sets for people that are good at these, and you could look up spatial relations. Those people who are good at spatial relations have certain jobs that they really enjoy because it fits the way their brain processes information from 2D into 3D. Okay, so that is all that I have for you for this week. And there are no solutions recordings because everything you're doing this week is talked about in this recording. So there's nothing else to post for a solutions recording. And that'll be all for this week. Thank you very much.